introduction to thermal analysis inside Ansys Workbench. In this lecture, I am going to tell you how you can access thermal analysis inside Ansys Workbench. So, accessing thermal analysis. So, you go to the analysis system, you are going to select the steady state thermal analysis and you are going to drag it and place it on the project schematic. Then, coming to the basic equation of thermal analysis, it is nothing but KT into T equal to Q of T. And what are those assumptions? So, we don't have any transient effects that are considered. K is constant and this particular K matrix is a function of temperature. Q is constant and Q is a function of temperature, and fixed temperature represents the constraints on the systems. So what happens, as like in the displacements that define the constraints in a structural analysis, here the temperatures heat generated are the constraints to the body. Then coming to the geometry, you can use solid as well as surfaces as well as line bodies. That means you can use 1D bodies, 2D bodies as well as 3D bodies for performing thermal analysis. Then coming to shells or 2D bodies, the temperature may vary over the surface only. If the temperature is varying throughout the thickness of the shell, it cannot be modeled as a 2D problem. Likewise, if we take the line bodies, if the temperature is going to vary along the length, it is okay. But if it is varying along the thickness, no, we cannot take this assumption as a line body and we need to perform that simulation in 3D only. Then coming to contacts, there are different contacts that are automatically generated by the software itself, which allows for the transfer of the heat in assemblies between the parts in assemblies. Then coming to the material properties, for basic thermal analysis you only need one single property of the material, that is thermal conductivity. But based upon the type of analysis you are going to perform, let us say if you are going to perform a thermostructural analysis, you need to be giving out the Young's modulus and Poisson's ratio as well as the coefficient of thermal expansion alpha. So based upon the analysis, you need to give the properties. For basic steady state thermal analysis, you need to be providing only thermal conductivity as an input in the engineering data application inside Ansys Workbench. What are the different loading and boundary conditions? So what happens is the loading conditions and the boundary conditions include temperature, internal heat generation as well as flux, then radiation, convection conditions, etc. So what happens is inside thermal analysis, we can either provide temperature or heat flux or internal heat generated or convection boundary condition or radiation conditions as the loads and the boundary conditions. Then coming to the results, what are the results we are going to find out? We are going to find out the total and directional heat flux on any face or the body, and then we can also find out the temperature distribution. We can find out the reaction values at different temperature boundary conditions, and we are also going to find out the contact status. So in addition to all of these things, we can also animate the results so that we can find out the flow of heat from which position to which position the heat is going to flow, and other sorts of things we can understand well by using the animation feature available inside Ansys Workbench. In the next lecture, I am going to introduce you to thermal analysis inside Ansys Workbench using an example.